In this video, we're going to focus on similar triangles. Now, in a previous video, we learned that there are two conditions that make a polygon similar. The first condition that makes a polygon similar, or two polygons similar to each other, is that the angles, corresponding angles, have to be congruent. And the second condition that makes two polygons similar to each other is the fact that corresponding sides must be proportional. So I'll actually write that down because it's the corresponding sides that's super important. Must be proportional. And we spoke about what that meant. If you don't remember, maybe you can look back for a second and come back to this video after. Alright, so proportional. Okay. So once you are there and you understand these 2 points, now you're ready for this video, which is specifically focused on similar triangles. Now the good news is this: you don't have to check for proportionality for all corresponding sides, and you don't have to check for congruence for all corresponding angles. All you have to check is a couple things. So, for example, there is something called the angle. Yes, I said it twice and I meant to say it twice. So for short, the AA postulate. So if you have two triangles, let's put them here, and we know that we have two pairs of congruent angles, that alone is enough for us to tell that our triangles are similar. So I could then ask you, I could give you a little bit of information. I could tell you that this is 30. I could tell you that this is 90. I could tell you that this is 90. And I could tell you that this is 60. And then I could say to you, hello, do you know whether or not these two triangles are similar? And you'd say to me, well, hopefully you said yes, because if you find the third angle here, you would know that that third angle is 60, and all we need to know is two angles to tell whether or not our triangles are similar. So there are a couple other ways to tell if our triangles are similar without having to look at every single thing. So we'll look at the others right now. Another way to check for similarity in triangles is to use the side theorem, SSS theorem for short. So it's exactly what it sounds like, but I'll explain. Alright, so as you know, we need to have pairs of corresponding sides in order for polygons to be similar. So let's say we have two triangles, and let's say this is 5, let's say this is 4, and let's say this is 7. And over on this side of town we have 2.5, we have 2, and we have 3.5. Well, this triangle is exactly twice the size of this triangle. If you have all three sides and you see that all three sides are proportional to each other, well, the corresponding sides, of course, are proportional to each other, that is enough to tell that our triangles are proportional. We don't actually have to check the angles. They will be congruent if you do check, if you use something to check, but you don't have to check. That's enough to know that these triangles are congruent. Not congruent, sorry, similar. Alright, so these two triangles are similar because we've checked the sides and the corresponding sides are proportional. Alright, there is one more way to tell if two triangles are similar. Okay, so the third way to tell whether or not two triangles are similar is to use the side angle side similarity theorem. Sounds fancy, but it's not too bad. So the side angle side, oops, not bad at all actually. So the side angle side similarity theorem, call it SAS theorem for short, SAS similarity theorem. Alright, so it again is exactly what it sounds like. So all you really need to check for, let's make this one bigger. All you really need to check for is a side and two sides and the angle between. So let's say you know that this is 3 and you know that this is 8. and you know that this is 6, and you know that this is 16, and let's say this is 40 degrees, and this is 40 degrees, nothing else really matters. We don't need these two angles, and we don't need this third side. All we need to check is that the angle, the one angle that we do have, is congruent to each other, and that two corresponding sides are proportional, and in this case they are. 3 and 6 are corresponding, and 8 and 16 are corresponding, and this is true. So since we have two pairs of corresponding sides and two congruent angles that are in between those sides, then we know that our triangles are similar. Alright, so let's take this information and let's look at an example. Okay, so as you know by now, in geometry, you can never just make a claim or make an assumption and just run with it. You have to be able to support every decision you make. So I'm going to say, and then support, but I'm going to say that triangle ABE is similar to triangle ACD. And why am I saying that? Because they look similar? Absolutely not. I have a reason to support what I just claimed. So as you can see, there are two parallel lines here. Now these two parallel lines here at the top end is being cut by one line. That one line is called a transversal, as you may or may not know. So that transversal, when it cuts two parallel lines, it creates the same or congruent angles. So we have a congruent angle here that is congruent to an angle here, because we have two parallel lines being cut by a transversal. On the bottom end, same thing is happening. We have parallel lines being cut by a transversal, and for that reason, this angle must be congruent to this angle. Now, as we just learned, all we need in order to determine whether or not two triangles are similar is two angles. And we have that here. We have two angles. So from that, we can tell that triangle ABE is similar to triangle ACD, because we have our congruent corresponding angles. Alright, great. Now that we know that, we can set up a proportion in order to figure out what x is. So, we do know that AB, side AB, and side AC are corresponding sides. So, AB over AC, since they are corresponding sides, will be equal to BE, and I'm getting that from here. Let's do this. BE, the second and third letter, over CD. So that's equal to BE over CD. Alright, so now that we have our proportion set up, we can now just plug in our numbers. So AB is 3 over AC, which is 5, is equal to BE, which is x, over CD, which is 3.5. Alright, and now we can cross multiply and finish this up. So we multiply that by that, and this by this, and we get 3 times 3.5 on the left side is equal to 5x. Now 3 times 3.5 is 10.5, and that is 5x. And we're trying to isolate our x, so we can go ahead and divide both sides by 5, and we get finally that x is equal to 2.1, and that is our unknown length that we were trying to find right here. BE is equal to 2.1.